All right, welcome back to Live Demon Programming. I'm Bill Westlake, and this is the C++ introductory course where we're working on our dungeon crawl game. One of the things that we want to do with our game is allow the players or people in some way to modify the way the game works, or the person wanting to set up the game possibly as a server-based thing, which we may do in the future. But for the moment, what we want to do is embed a language into that game. And the language that we're going to embed into our game is called Python. I'm sure you've heard of it. We're going to use Python 3.8.6 RC1. And so I picked certainly the latest thing. This was released in September, on September 8th of 2020. So from my time here, just 12 days ago. So this is the latest and greatest. That'll give the greatest longevity to the video, because if the Python gets too old compared to the video, then people have kind of a struggle. So what you're going to want to do is come down here where it says Files. Now we're building for x86 in our application, and we're doing that for a reason. For tutorial purposes, not everybody may have a 64-bit machine, so I chose to set the entire thing up as 32-bit. What you'll want to do, if you're following along exactly and doing everything that I do, you'll want to install this Windows x86 executable installer. You can simply click on it and download it, and I've already downloaded it, so I'm going to cancel out of that. And install it on your system. Now, when you install it on your system, there's a couple of things that I highly recommend that you do. Visual Studio sometimes has trouble with very long paths, and the default location for this install is in C, users, your username, app data, local roaming, down a long directory structure. Not only can it be hard to find that directory when you need it, but Visual Studio may at times have trouble with that very long path for include paths and stuff. So what I have done is I've installed it, and you can do this simply when you go through the installation. You want to choose customize installation, and a couple of steps into that installation will let you choose the install path. Now I chose my drive D because I've got tons of space on my drive D, and I put it in the root of drive D as Python 3. Now if you've only got your C drive, that's fine. You can stick it in the root, or you can stick it in program files if you want. That's not a terribly long path, but I highly recommend you get it out of that app data folder buried deep in your user directory, and put it somewhere on a drive, or even on a thumb drive if you want, as long as you know where to find that file. And I called it Python 3. I also put it over here because I've got several versions of Python installed, because I have different tools and applications that use different versions of Python as their embedded language. So you'll just install it, and it should look like this in your install directory. Once that is done, you'll want to come into Visual Studio, into our game, and on Dungeon Crawl, right click and select Properties. Under Properties here on the left, you will see VC++ Directories. You'll select that, and here is Include Directories. And you'll want to pull this down, click on Edit, and here you'll see that I've got D\Python 3 include. And you can get to that simply by clicking this Browse button if you want, and going to it. There, it's added already. And put that include in that directory entry for those include directories. Then down here under Library and Directories, and I'm going to go ahead and do this because I'm going to show you something to watch for. You'll notice it's D:\Python 3\libs. This will want your installation directory, by the way, not just mine, unless you happen to have a D drive and do exactly what I did. But when you look at this Python 3, you'll see there's a lib directory, and there's a libs with lowercase l, ibs. This is the one you want, libs, not the lib directory with a capital L. And we just click on OK and OK, and we're good to go. Now, there is something a little bit tricky here that I need to show you. And that is that Python ships with only release libraries. So what do we mean by release libraries? Well, these don't have debug symbols in them and can't be used for debugging. And if you just put the include folder in here, it's not going to be able to link because it's not going to be able to find the debug library that goes with that header file normally. So we have to turn debug off when loading this include file. Now I'm just going to put this in here for the moment to include Python in this. And so what happens is if we're in debug mode, it's going to undefine debug mode, include the Python header file, and then redefine debug mode. Otherwise, it's just going to include Python. So if I go up here, I'm in debug. If I come up here and select release, you'll see my highlighting system switches, and this is now the one that's active. But we're going to stay in debug for now. Now, later on, we're going to move this to our own header file so that we can just include our own header file just for this that we'll call Python 3 or something, .h. That'll just have this in it so we can simplify that wherever we need Python in our application. All right, so far so good. We have Python in there. Let's make sure that it compiles and runs with that header file in place. And it does. Okay. Now I'm going to temporarily disable my main function by putting a slant in front of there, because we're going to make a new main function, and we're going to call it int main void. We're going to do return 0. If I haven't mentioned this before, main in C++ standard, in order to be correct about it, you should either have int argv char pointer argv as the what is it under? Oh, because the wrong one there. argc as the standard inputs to main, or if you know that no command line arguments are being specified, you should put void in here. Also, main should always return a 0. I believe that in previous videos I didn't do either of those two things and didn't really explain it. To be canonical, if you don't do this exactly, this pattern, and returning something, you can return an error code as well. You don't have to return 0, but you must return something to this. The C++ standard says it's undefined behavior, which on some platforms might give you trouble. So, what do we want to do? Well, we want to test our Python installation, and we're going to do that very simply. And we're going to do that with some things that are included in this header file. We now have access to some Python things like Python PyObject, and we're just going to call this something like pint. Now what we're going to do is call a function, and I will explain these. It's going to be pyinitialize. And then we're going to call run simple string. And we're going to put a Python call in here. Hello world from Python. So what did I just do? This is actually Python code here inside this string. It's a print statement with hello world from Python, and this is going to execute that inside the Python engine as though it were a Python statement being sent in from anywhere else. And then what we're going to do after doing that is call pyfinalize. Okay. Now, I will tell you there are some tricky things about pyfinalize that we have to take into account later. But right now, this is okay because we're not dealing with any objects returned from Python. But eventually, we're going to have to worry about a few detailed things, and I will explain those when they come up. But for now, what we can do is run this program, and hopefully it links, and hopefully it runs, and there we go. Hello world from Python. So what happened there? This string that represents some Python code got sent into, by this call, the Python engine. PyInitialize, I don't know why I have that Py object int on there. Probably because I was supposed to go print equals. This is what does this return? This only returns, does it return anything? It doesn't seem to like that. Okay, I had it in my notes to have that there, but I don't believe that this is actually necessary. We'll run it again and make sure. Yeah, no, it's not necessary. So there it is. Hello world from Python. PyInitialize sets up the Python engine. It initializes everything and gets it running so that it's running in here. And PyFinalize shuts down the Python engine. And we need to call both of these. And we need to call this just before our program exits. And perhaps under some other circumstances there. So Python is now working perfectly in our system. So let me check the time here real quick. So we're about 12 minutes in. So we'll do one more quick test, and then we're going to wrap this video up. And in the next video, we're going to start getting into more detailed use of these things. Let's do another function here. Let's look at how values work. Okay, so I'm going to copy paste some code and then explain that code. So we'll just call this, we'll rename this to main1, and we'll create another main function. I'm going to copy paste some code in here. Oh, I already had a return. Okay, no, we haven't done CPy instance yet. So what we need is PyInitialize, and then we need Py object P. That's supposed to be a pointer. And this should now print out the value 50. Now, what's this doing? Well, I'll explain it first. Well, we're initializing. We're creating a Py object. We will find that Python returns Py object pointers and takes Py object pointers as parameters only. That's all you can do is receive and send parameters. But there's a series of functions to turn those Py objects into whatever you need them to be. So in this case, we know it's a number, so we're going to convert it to a long, and we're going to print it out. So let's run this and see what it does. And here it says value equals 50. So what's happening there is all we're doing is using the pylong from long function. So it's taking this, assuming it's a long. We could actually stick an L after this. Value equals 50. And then it's taking that pointer and it's calling pylong as long. So what this as long is doing is turning the Pi object returned from this, you'll see that there it says Pi object is returned from this, and turning it back into a long, which we can print out. So things are working, and they're working well, and so I think I'm going to end this video here, because in the next video what we're going to do is start creating a couple of objects that are going to help us work with all the different features of Python a little more easily by having some classes that handle some things for us. So that's it for this video. Thanks for watching. I hope you enjoyed it. If you liked the video, hit that like button. If you really liked it, hit that subscribe button. And if you want to get notifications when I upload videos, hit that notify button. Thanks, and I'll see you in the next video.